Hello, everybody, and welcome back to Blockchain Won't Save the World. The students are back, and today it's Aussie students react to blockchain. And we've got a really talented group from UNSW in Sydney, Australia, to talk us through some of the most interesting blockchain projects that they've seen. We're going to talk through what they like, what they don't like, what they'd like to know more about. And kicking us off is Ambrose. Ambrose, you're going to talk about Algorand, right?
Yep, that's the one. So Algorand is a generalized blockchain platform, and it was proposed in 2017 by Silvio Micali. But sort of what is a generalized blockchain, right? So most people now have heard of Bitcoin and blockchain in general and have a basic understanding of what they are. However, a lot of the time it just gets simplified to cryptocurrency or crypto. And so the next step in this blockchain technology is to create a platform that allows for more complex applications that can do more than just transfer tokens and currency between users. And this is the goal of Algorand. In fact, their vision statement is a world where everyone creates and exchanges value efficiently, transparently, and securely. So now just for some quick background on Algorand and sort of what they're doing in the blockchain crypto space. Firstly, the creator, Silvio Micali, is a world-famous cryptographer known for his work in zero-knowledge proofs and public key crypto systems and other areas in that field. This gave Algorand some initial trust as it had a somewhat famous name behind it. And then from a technical standpoint, Algorand is doing some really cool things in the space. It's been marketed as the first pure proof-of-stake platform, and it uses a modified proof-of-stake consensus algorithm that provides near-instant transaction confirmation with a high level of security, allowing it to be a public permissionless blockchain, meaning that anyone in the world can, with an internet connection, can join and participate in the network. I'll just quickly go over the three main components of the consensus algorithm because it is actually really interesting from the technical point. So as I mentioned, it's split into three mechanisms: the block proposal, a soft vote, and then lastly a certify vote. So in the first block proposal stage, random participants are selected to propose blocks, that is, add transactions to the chain. Then in the next stage, a completely different group of participants are chosen to reduce those block proposals down to just one block. And this is accomplished via a weighted vote. And then lastly, a third group of unique random participants are selected to certify the block proposed in that soft vote. This last step is more of a validation step. It's to check for the double spend problem, overspending tokens, and sort of other faults in the transactions. The security in the consensus algorithm comes from the fact that in each stage, the random participants are selected privately using a verifiable random function. Since the participants for each consensus round are selected privately, adversaries don't know which peers and nodes to compromise, as by the time the participants of each round are revealed, they've already completed their roles. And then as the user base grows and more users become a part of it and are participating, it becomes increasingly difficult to launch any sort of network attack on Algorand. With this, Algorand has quickly become a well-established generalized smart contract platform with many developers and partnered organizations that allow for almost any sort of application. I'll briefly just touch on some of the areas it's currently being used in, and then I'll just mention two use cases that I think are really, really interesting. So far on Algorand, it's been used for infrastructure, supply chain, the public sector, gaming, digital assets such as NFTs, privacy and identity applications, and then of course the big one, decentralized finance. So just two quick use cases that I think that is super interesting and showing sort of the versatility of Algorand. The first one is the Marshall Islands. It's become the first nation to adopt a digital currency as their national currency, with the goal of envisioning a more open economy for its citizens. This was announced back in March of 2020 and has been under really strict criticism and close watch, as this could be the start of governments accepting and establishing cryptocurrencies. Depending on the adoption rate, this could have large and lasting impacts on the global economy. One advantage of this sort of currency being adopted by a government is that you can actually codify the fundamental economic mechanisms via smart contracts, such as inflation rate, which starts to limit the influence that large central financial institutions have on the currency, which is sort of the standard system most governments run now. The second sort of use case is Meld Gold. And so Meld operates as the standard crypto token. However, they have the unique idea of pinning each of their tokens to a metric gram of gold that Meld stores in their own private vault. this gives the token a foundation for its pricing, because it's pegged to the price of gold. But it also gives users and the traders of metal gold the safety of investing in the precious metals market without having to store any of the metals yourself. This allows for users to invest in real world assets, but only via a cryptocurrency. And so now that's sort of like a background and a summary of sort of what Algorand is. But what I really like about it and what I find really fascinating is that how generalized it has become. I've only touched on sort of 2 of the use cases, but it is really being used in a ton of areas. And I think it's probably going to be going to only grow in the near future, in the coming years. One concern that I do have, though, and I'll pose this to the group, is with the rise of these sort of generalized blockchains that are allowing for multiple applications, are we going to see competitor platforms rise up like we did with like the streaming services? Netflix had a monopoly for many years, and now every media company has their own sort of streaming service. Are we going to see Algorand dominate for some years and then have everyone else sort of create a competitor, creating a sort of a fight for the top blockchain, I guess?
Ambrose, brilliant introduction. Thanks for kicking us off. Loads of research there. Also a couple of Aussie references there. Mining for gold, Marshall Islands just down the road. I love that. Really, really good start. Team, come in on this one. Any thoughts around how you think the blockchain protocol battle is going to play out, or any other reactions to what Ambrose has put on the table? If not, I'm going to come in with a quick thought. I think the generalized blockchains, there are several, right? And if you look specifically at tokenization platforms, you've got Ethereum, you've got Algorand, you've got EOS. There's a number of different ones which are basically performing very similar functions. Proof of work versus proof of stakes getting a lot of attention at the moment, specifically from, and this is something that I talk to enterprise clients, to large organizations, and they say, tell me about the sustainability profile of your blockchain, or which protocol you're using. And this is something that non-blockchain experts are now aware of, whether it's because Bitcoin has had particular visibility or lender visibility to the computational complexity and then the energy requirement to maintain kind of mining and validation, or whether they genuinely are just making sure that they're across the board on sustainability with everything, whether that's cloud, whether that's blockchain, any of it. But this is in the public and this is in the enterprise domain. So it's worth thinking about. So yeah, I don't know. I mean, what's your view on the other competitors or the other kind of main alternatives?
Yeah, well, I said it in my little summary, but it's the first pure proof of stake platform, whereas Ethereum for many years has actually been, they have a roadmap to convert from proof of work to proof of stake. However, there's sort of issues, and everyone on the network is sort of fighting over when they should switch and which algorithm they should switch to specifically and things like that. Whereas Algorand just started straight off the bat with proof of stake. I think proof of work is slowly going to stop being used. It's just socially unacceptable for the energy use. I think Bitcoin uses something close to like the energy consumption of Denmark or Belgium or something like that on a year round. So it's just not sustainable. Whereas proof of stake provides faster confirmation times, as well as just providing a more sustainable network that I think will sort of see a larger adoption for sure. But that is definitely a large talk of it, and I expect that to continue in the near future.
Brilliant. Great start, Ambrose. Thank you very much for kicking us off. Regio,
Yep.
You're up next, and I believe you're going to talk about Quorum.
Yes. Hello, everyone. So thanks for having me. I'm going to talk about the Quorum blockchain. So I'm going to follow the same line that we already are discussing before about the private and enterprise blockchains. So the idea of Quorum starts in the end of 2015, beginning of 2016. The Quorum was created by the JP Morgan Chase. That was when it was created. The idea of Quorum basically is a client that works for Ethereum. So the Quorum relies on the Ethereum network and the structure. Once we know how Ethereum works, we have the base for Quorum as well. At the very beginning, the Quorum were created by for JP Morgan, making a fork from the GAF. GAF is the main client for Ethereum network. So JP Morgan made a fork for it, and on top of this this code, they build up the Quorum. The biggest focus of the Quorum on its conception was looking into an enterprise solution. So this blockchain was conceived to work as enterprise. Later on in 2017, it comes the first use case in which they run a pilot of the Quorum. So as JP Morgan had access to the IIN, which is in Interbank Internet Information Network, which has around 400 banks. And they on this pilot, they try to minimize their friction in cross-border transaction by enabling payment and research beneficiary, make this transaction happen faster on this use case. Later on in 2020, last year, the Quorum blockchain were acquired from JP Morgan. It was acquired for a company called Consensus. So now Consensus is the owner of the Quorum blockchain. Under the Quorum umbrella, there are two main projects. One of them is called Go Quorum, which is a Quorum client implementation using Golang. And the second one is called HyperLedger Besu, which is also a Quorum client implementation, however, implemented in Java. The biggest benefit that we can foresee in the Quorum is the creating of private transactions. Why this is important? Because when we are talking about developing a blockchain that is going to run in an enterprise environment, a bank or an enterprise doesn't want to share some personal or some private information with everyone. Different than what we have in the Bitcoin or the public network, Ethereum public network, where all the information is public available. Anyone can see the information. When we are talking about enterprise network, I don't want to share my account balance with everyone. So this is kind of a private information that I don't want to reveal. So having this idea in mind, Quorum has the private transactions. There is inside of to create the private transactions on top of Ethereum network, the Quorum client had a module called Tessera. This module Tessera is responsible to manage all the private transactions on top of inside of a Quorum. Tessera has two different modules, two submodules. One module is called Enclave. The Enclave is responsible to perform all the encryption, decryption, hashing, all of these mathematical operations and security operations are performed by the Enclave. While the second module is the Transaction Manager, where all the transactions are validated, all of the communication between different peers are established and the information is exchanged. The communication between these peers happens using REST protocol, using TLS, so all the information is protected. Another thing is that this client, the Quorum client, allows some certainty of customization. So on Quorum, currently we can deploy different consensus, as we were discussing before, like supporting multiple different consensus. So Quorum currently supports the Raft consensus, the Proof of Authority, and the Istanbul PBFT. These are the consensus that are supported right now. And the clients, they are identified in the network by their public key. So that's how the clients are identified. Coming to some customers, so who are the customers that are using the Quorum blockchain right now? We can say on the Consensus website, they have a couple of companies. I find some of them more interesting, like IT companies like Microsoft. There are some banks like JP Morgan and World Bank Group, all of them using Quorum. Some telecommunication company like T-Mobile, and some supply chain company called Coventis. And then Coventis provide in this in the website a good use case, where this company initially they have a lot of manual and physical operations to do all of their supply chains, and they adopted Quorum as a solution to removing all of that paperwork, all of that physical controlling, and now they migrated all their solutions to adopting Quorum, and then so far they are all the results are very satisfying. So for all of this adoption. At the end of all of this, I can raise one question. One thing that draw my attention for Quorum is that the idea of a private transaction. That's something that's really interesting, and from a point of view of enterprise, is one of the greatest benefit that you can achieve. However, with the private transactions, we have some issues like how you are going to audit the specific transaction, or how we are going to avoid the double spending when you have transaction, private transaction, how you're going to make these operations. So on top of this, there is one point of extension, or a point of research, open point for research in this, is that applying the zero knowledge proof, because this is a way how you can audit a private transaction without revealing what is inside of transaction. Let's say Regio's account has $10. However, how you are going to check that Regio has $10 without reveal this balance? So we can use the zero knowledge proof to make this kind of challenge, and then Regio can prove that he has this value inside of his transaction without revealing this information. This is one thing that's kind of very interesting, draw my attention for Quorum. And that's it. Thanks.
Regio, thank you so much for the detailed research and the interesting introduction. I think the crossover between private and public chains is something that a lot of people have been focused on for a long time, particularly, I mean, financial services, you've got a significant amount of regulation specifically to KYC, know your customer, know your client, know your entities in the system. So permissions is always challenging. And the ability to cross over from private networks, right, private channels where you've got information that's only visible to some versus visible to all, super interesting, super important functionality. I think, you know, it's interesting to see that there's probably still nascent adoption of Quorum. If you look at how many examples of Ethereum or Hyperledger are being used on some of the more common platforms versus Quorum. I don't know whether there's work to catch up, or the zero knowledge proof angle to that will accelerate use after the fact, because that's going to help them kind of complete the single view. I don't know. Anybody else had any experience with Quorum? Any other thoughts based on what Regio said?
Not with Quorum specifically, but Hyperledger Fabric sort of gets around the sort of private transactions by creating this idea of channels and having like blockchains on top of blockchains that only specific organizations have permissions to, and things like that. But it would be really interesting to see that if they do manage to solve that sort of private transaction on a public blockchain, what sort of applications will we see? Like, for instance, will we see them sort of move into like CBDCs, or you know, so that's sort of more I guess not formalized or more centralized, like financial institutions, and sort of trying to take over them in that way. But yeah, it will be very interesting.
We could definitely
this idea of creating the multiple channels is what the Quorum introduced with Tessera. They create this peer-to-peer connection, a different connection that do not go through the Ethereum network. So they use this another channel to make the private communication rather than using the public one.
Very good, very good. And it's interesting to think the battle for CBDCs is quite prolific at the moment. You're seeing pretty much every major established protocol being used in different settings, and it's a little bit of a technical trade-off. It's a little bit of sometimes personal preference. In some cases, they want to use Ethereum because of tokenization. In other cases, Hyperledger is being used, and you're creating a token concept that doesn't use ERC20 or ERC721, but you are still able to create the concept of tokenization. So anyway, we'll see where that one goes. I'm super interested to bring Sidra in on this one, because Sidra, you're wanting to talk about Helium, right?
Yes, my topic is Helium blockchain. So the concept behind Helium is similar to Uber and Airbnb, which allow people to monetize their cars and spare rooms. Helium, which was officially announced in July 2019, is innovative as much simple, where you can have a small device connected to your home internet. And this device can provide coverage to the nearby IoT trackers and can earn you Helium cryptocurrency, which can be exchanged for real currency. So that's the concept, and how, more technically speaking, how it works. It's basically a hotspot, which is designed to provide a long-range wireless network for low-power sensors and trackers. The backend protocol which it uses is LongFi. It's a combination of LoRaWAN wireless protocol and Helium blockchain. which works pretty much similar to how cryptocurrencies work, such as in case of Bitcoin. But instead of proof of work, Helium blockchain uses proof of coverage. So now how proof of coverage works. So proof of coverage basically verifies that hotspots are located where they are claimed to be, or in other words, on continuous basis, if those hotspots are honestly representing their location and the coverage they are creating from that location. So now there are two good things about and interesting points to note about Helium blockchain that I think are important to mention. One is the level of automation and the ease of setup that it provides. Essentially, what you only need is to set up the device in your and connect it to your home internet. And what you are basically doing is you are empowering the IoT concept by providing more and more network coverage to the nearby IoT devices. The second good thing about is that how proof of coverage works. Essentially, it's preventing people from buying loads of hotspots and keeping them in their home. So essentially, you cannot do that the way the proof of coverage works, and you can only have one device in one location. So the downside I see is that the people, while using it, are concerned that how much money will they be able to make by the end, because it depends how much your hotspot is used and how close it is to other hotspots. The cost of initial device is not low. It's around $500, and people would want to recover that price as soon as possible. But depending upon the usage of the hotspot, it is not certain that you would be part of proof of coverage. Your device would be a part of proof of coverage, which can essentially earn you more money, or it won't be a part of proof of coverage. So I think that's a bit of concern for the people. And yeah, and in my perspective, I would my concern about it is that how to ensure that how secure it is, how much trusted it can be. The reason behind is that there are lots of possible attacks on LoRaWAN devices, and since the backend protocol does rely on LoRaWAN wireless protocol, are there any possible attacks which can really disrupt the working of Helium blockchain itself? So I think that's the concern at my end, and I'll leave it to you. Thank you.
Sidra, super interesting. Really, really like this example. I mean, the idea of providing sort of democratized Wi-Fi coverage for sensors is super, super interesting. In terms of challenges around scaling, definitely see that, individuals, you've got to get a lot of individuals' homes to be able to get that scale. But if you start thinking about the enterprise space, those that have multiple locations, imagine a Starbucks or a Costa Coffee or somewhere, clipping into Helium protocol and making crypto to enable sensors and other devices, locations that have got, multiple McDonald's, whoever it might be. You've got a really interesting angle there. I wonder from a bandwidth perspective, whether there are any challenges of, where families have got lots of different devices going on at the same time. Security is one. Tax, you mentioned tax would be a really interesting one for me, because if you're reselling theoretically, a service which is your Wi-Fi bandwidth, is that a taxable asset for individuals, and how do you manage to account for that? How do corporations account for that if they want to play into that? So really interesting. Anybody else had a thought on Helium or come across this one before? If not, we'll jump straight ahead. So Gian, you picked a popular one here. You want to talk about OpenSea, is that right?
Yeah, I'll be talking about OpenSea. So, okay, so many really more detailed ones. So this one is going to be less brain hurts for me. So, okay, so for the OpenSea, right? So OpenSea, it's actually, currently it's a platform, we can call it as a marketplace to buy and sell the NFT or non-fungible token, which is like the token that is unique and like immutable, that could be, you can look at it as a pointer that point to some asset, like mainly digital asset currently, because it's more convenient to deal with and interact with the platform. So the OpenSea currently run on the Ethereum network, but they just declared around the beginning of this year, around February, that they have a plan to extend to Tezos as well, because that's one thing. And the platform itself mint the token with the standard of ERC 721. So it's pretty much the standard to make a like a unique token, and it has minimum interface to be able to manage, to own, to trade the unique token among users within the network. So and for this platform, like it allows people or user to mint the token from so many things. Let's say the artwork, we can see so many crypto arts and so many like news talking about it. Let's say some people just burn the Banksy artworks around like last year. And then something else like music, or even like a domain name, like some popular domain name gets sold really expensive price, or even all the digital asset inside some virtual world or some video game that run on top of the blockchain network also can be considered as an asset and be mint, and of course it can be sold on the network. So this is really like really broad feature, and that's the reason why OpenSea or this kind of NFT area become one of like really biggest area that people from non-technical background or know nothing about blockchain start to get like to start or get a touch on what blockchain technology is. So many, I would say I'm from, I'm currently in the Thai digital artist community, and many of artists there currently like start to learn how to use MetaMask, how to transfer, how to mint the art and sell on the OpenSea. So, and you can see like there, aside from like burn the Banksy artworks, there's also like some internet memes like the disaster girl, which is like the memes that the girl smile with the burning house. That one, the woman inside the photo, which is like actually herself, sold that as art on the NFT platform, and it can get up to like $500,000 US. So it's really like new and interesting thing. But so what I actually really like about this is that it provides so many opportunity to do, not only the artists, but so many people start to find a way to make money or make benefit from this. Let's say some people that really good at digital or pixel art. Some of them play some virtual world. Currently, there's a platform for virtual world like Decentraland, or another one called Sandbox, which is pretty much like a video game that you have a character inside the virtual world. You can create some asset, just create some cosmetic vehicle, and then you mint a token and sell it inside. So like some people actually make a money and make a venue on top of this, which is really good opportunity. Like it's not only limited by the crypto arts or like all the painting or digital arts. And another thing that I really like this platform is about how the token is mint, because there are other platforms for NFT marketplace as well. For example, the Rarible, but this one, when you want to list some of your artwork, the token gonna be mint right after you list it. So it means the seller have to pay the gas fee to list the works. But for OpenSea, you can list how many as you want. You can edit the price. You can do whatever you want, and the token gonna be mint at once only when the art gets sold. So, and which save a lot of money on gas fee for the artist side or the seller side, which is really good. But at the same time, when it's get this popular, there are so many concerning points, and something that I'm not actually don't like, but really concerned about this. The first thing is that the proof of the work, like the proof of the token, the work that lists inside the platform itself, because people currently, especially from non-technical background, they look at the NFT as a proof of the originality of the work. Like you use this piece of work, you mint the token from it. So it's the pointer that point to that artwork and say, this is the original work. But in reality, it's by the platform, because everything is so decentralized. It's so difficult to say that, oh, what if I just download or screen capture some artwork, some piece of work from my phone, and then I mint from it. I mint the token from it. I sell it. So there's actually no way to prove this now. So it means like people in the currently both the buyer and the seller really have to be really careful before they sell or buy the artworks, that like, oh, the token itself is a proof of originality of the work, but not the originality that it actually comes from the artist. And over the past 2 to 3 months, there are so many cases happen in, I believe, so, like other community as well. But because I currently from the Thai artists, they like some of the work that being produced, like there's one artist, she made some digital artwork illustration and it get viral as a memes on the internet like 5 or 6 years ago. And then her work got mint as a token by some random guy and sold on the OpenSea. And currently the only thing you can do is just that you have to contact with OpenSea and prove that you are actually the real artist, and then they will remove that list off from the system. So it's not actually like that is quite difficult to say and to protect the artists themselves as well. And that's why just not only how beautiful or good the work is, the other thing that makes the NFT or that piece of work has a value is the proof of the artist that I'm actually that person. And some artists decide to rely on some centralized company or physical documentation that prove that I am that artist. And so I kind of have a question, if you still have to rely on that, so why use the blockchain in the first place? Or is there anything that blockchain can do to solve this problem? And another thing about the OpenSea that I'm kind of concerned is the carbon footprint that generate from this, because the OpenSea itself actually currently run on the Ethereum network. And we can see that like the carbon footprint that come from one single transaction is like 39 kilogram of carbon dioxide, which is it's actually high. And it's not just only when you mint the token, but when you transfer, when you trade, or when you like do anything about it, it's cost as this much. But of course, because Ethereum community, they plan to change the proof of stake for the Ether 2.0. So that's another solution that could be. And also the fact that they explore themselves and about to collaborate with the Tezos network. So that could be another solution as well. But yeah, it's still a problem at the present time. And but yeah, I think that's pretty much for me. And it's really interesting and concerning point that you think for the big challenge for the community to solve this as well. So yeah.
Gian, thank you so much for that. Really, really great in-depth. And also specifically that you are an artist or part of the artist community, so you have a particular stake in this particular type of platform, I think is super interesting. A whole bunch of challenges in there, right? And in terms of the authenticity, what blockchain and OpenSea and tokenization generally has given us is democratization of being able to find a platform to launch content. Right, and you've seen a proliferation of hundreds and thousands or millions of tokens that may be of value, maybe of not, maybe fraudulent, maybe not. I had a conversation with somebody the other day, hopefully able to say more about this in future, but people looking specifically at AI algorithms to identify and vet whether IP on tokenization platforms or on minting platforms is already owned elsewhere, or being able to link some sort of attribution of IP if it's not original art or if it exists elsewhere, to try and reduce the risk of scamming and so on. But really, really interesting issues. And in a platform and a topic so early, you're going to see some of these teething problems, and it's I guess frustrating. But at the same time, your friends, the other artists that you work with, now have a platform for monetization, for sharing, that they wouldn't have had before. So I think that's super interesting. From the other students, do any of you other guys have NFTs? Do any of you guys have a stake in this? Any other thoughts from the group?
I don't have any NFTs, but I think it raises a really interesting question of the trade-off of this sort of like a concept that's been really popular in blockchain of rubbish in, rubbish out. Blockchains are only as good as the data that's being put on them. So you have all these immutable and decentralized functionalities and principles that come along with it. But if you're putting, incorrect or, wrong artists, or you're just taking data and you're putting it on the blockchain, then there's not much you can do. And it sort of there becomes this trade-off of, especially with OpenSea, of do you bring in some centralized authority that can sort of validate all of the NFTs that are being minted, or do you, as you said, maybe bring in some sort of other mechanism? And I think we'll push forward with that in the coming future, and hopefully get some good results.
I'd love to see a decentralized approach to this, is saying actually how could we do decentralized arbitration of IP? You look at there's a few other concepts around this. I mean, DAOs as a concept generally is something that's relatively mature now. Could we look at having a panel of, it could be automated, it could be non-automated, vetting whether we think a particular dispute or a particular piece of IP is owned? So rather than having a company, you could still open it up to the community. I don't know, anybody else from this group have an NFT or have any sort of participation or involvement in NFTs so far? If not, we'll leave it there. I mean, we could spend hours on this topic alone. Jan, that was a really brilliant overview. Thank you so much. Rahma, the topic of digital identity and self-sovereign identity has escalated significantly in the last 18 months for a number of reasons. And I believe you're going to talk to us about Sovrin.
Yeah, that's it. So yeah, so the main issue is the decentralized identity management. So identity management is always a complex issue because identity data is the most sensitive and the personal information. And in today's digital world, our identities are scattered everywhere. Most of us have lost track of the countless set of registration forms that we have filled on different sites and provided our personal identity information with kind of faint assumption that the provider can be trusted and will secure our data. So the result is, unfortunately, there's such centralized identity providers have become regular and easy targets for hackers. So we can have that kind of news very often. So self-sovereign identity concept actually just evolved, where the digital world no longer requires users' data, but can validate the identity by just accepting a verifiable credential that is issued to the user by competent and trusted identity authorities. So in reality, we can just sim it like each time we, the holder, can board an airplane or rent a car. So we can just prove our claims by opening our digital wallet and presenting the proof of our identity credential to a person or organization who needs to verify our identity or our driving license. So users actually do not need to reveal their full identity. Only the proof of possession is enough to reveal. So here actually blockchain takes the role of a trusted third party to create the trust between credential issuer and the verifiers. So blockchain mainly replaces the trust in a human or central directory with trust in mathematics, and thus basically decentralizes the identity management system. So simply we can say that blockchain technology allows the self-sovereign identity model to work, and self-sovereign identity allows people to own their credential data rather depending on some centralized identity provider. So the first well-known use case that I want to mention here is that the Sovrin. So Sovrin is a well-known organization that offers such self-sovereign identity solutions. Sovrin network requires blockchain for self-sovereign identity because blockchain is a cryptographic ledger with immutable records. And such kind of characteristics of blockchain aligns with Sovrin self-sovereign identity model. And another use case that I want to mention, which one is really exciting, that Estonia's identity system. So as a very first country in the world, Estonia has developed a blockchain-based identity system for its citizen. The Estonian government has deployed their blockchain and has integrated it with their e-health records and some other public services. So Estonia may be the only country where 99% of public services are available online. So with almost all public services online, it's said that Estonia saves 1,400 years of working time annually, which is pretty exciting. So the most important thing is Estonia's application of a digital identity service showcases many benefits of implementing self-sovereign identity. But despite that, not all countries actually accepting such solutions. We have seen, for example, we have seen several elections throughout the world has taken place face-to-face, even in the mid of such a worldwide pandemic situation as well. So that means people need to appear in person to prove their identity for voting. So despite of Estonian example, why other countries are not considering such identity solutions? So this is something like what I just concerned about, that is this something like the stakeholders from other countries are doubtful of blockchain's transparency? Yeah, so this is my first concern. And another concern about self-sovereign identity is that this is actually naturally imposes more personal responsibility from a security perspective. So considering time, money, and technology that companies deploy to secure their data, only to continuously suffer hacks, malware, or ransomware. So now think about shifting such security responsibility from companies to yourself. So undoubtedly, this is a huge responsibility. So any accidental occurrences like losing some secret key to open my digital wallet, so that kind of occurrence may be a reason of losing all identities overnight. So what I'm just wondering whether people are well equipped or technically sound to deal with these on their own. So this is the second concern. And another issue that I'm just curious about, that how this identity solution provider like Sovrin is going to convince the users that this is safe to use their identity credentials. So what I think that first it is needed to earn the trust of the public, because already some people suspect that like some other technology, verifiable credentials can also be abused for some kind of surveillance purposes. So this thought actually comes watching another decentralized identity platform called non-traveler digital identity that is specified by World Economic Forum. So allegedly, this decentralized identity platform is a surveillance by design approach, and which is also enabled through blockchain, biometrics, mobile devices, and cryptography. So that's the reason that some people suspect that blockchain-based identity solutions can be abused for surveillance purposes. So that's another concern, I think. Yeah, so that's from my point. So what do you think about this?
Rahma, absolutely brilliant overview. And this one cuts deep, right? Anything relating to identity or the sort of fundamentals of who we are, validating who we are, what we've done is always going to be polarizing. You know, we've seen a significant increase in the use of verifiable credentials as a concept over the last 18 months, particularly around COVID. And there's an important difference between a credential, right, that you have completed a test, your university qualifications, that you've completed the fire training, that you can digitize and share, that will reduce the burden of bureaucracy, that will make it easier to pass those credentials, but has a kind of lower burden of risk or concern or privacy compared to your driver's license, your birth certificate. I think a lot of the digital or digitization challenges relate to process change, right? So actually having governments go through those process change, make sure that it's equitable for all citizens, right? Because not everybody has a smartphone, not everybody is digital. How do we make these solutions still work? How do we make this interoperable across borders, right? So just because I have my university qualifications from UNSW on my digital wallet, if I want to go and study in the US or Brazil or Korea or wherever I'd like to, is the receiving party going to be recognizing that? Are they going to verify? Are they able to connect to the network? The scaling part of that network is also challenging, but we're starting to see pockets of proofs, right? Estonia is at one very long end of it. IOTA's travel pass is another that's in the same kind of broad bucket. IBM's been working with the Learning Credentials Network in the US for a long time, tens of thousands of academic institutions on there. What's going to drive this change? I think it's going to be time, honestly speaking. I don't know. I don't want to be the only one monopolizing this. So guys, please come in on this. How do you feel about identity relating to blockchain, or that blockchain is the rails helping to share the issuance and validation of your identity document?
As sort of you've already mentioned, the big one for me is sort of the interoperability. Is how do we know that if we do make the switch to one of these sort of systems, that it's going to be accepted at the places that we want it to be accepted? I think paper-based systems and the systems we have in place, or the centralized digital systems even that we have in place today, still suffer from these sort of problems, in the sense that, if I want to go to a university and travel overseas, I still need to spend a little bit of time making sure that they accept my credentials and things like that. But the other really large one is that how do you make sure that if we are going to make a big switch to this, how do we make sure that everyone can use it? Like, that not everyone has a smartphone, not everyone wants a smartphone, not everyone wants to be on the grid per se. But if you're going to make a large switch, the whole population sort of has to be on board for it to really work. And then that sort of leads to issue of, if there are going to be teething problems, people are going to make mistakes. How much control do we give individuals? Maybe we make sure that it's private and we guarantee the privacy of their information, but maybe not give them total control in case they delete their data or, something along those lines.
Yeah, that's the true concern actually. But yeah, I agree with Anthony. Yes, there's actually the time.
I'm hugely positive about this space, and Rahma, you've beautifully covered a huge number of the key considerations. And the more people are aware of those things, the more we can start to work around them. And the more proof points that we have around how the technology is being used, the greater chance it has of scaling further. So I'm very confident about this particular space. Samuel, I want to bring you in next. Shout to bringing in PowerLedger, homegrown Aussie blockchain proposition. Take us through it.
Yes, certainly. Thank you, Anthony. So PowerLedger is, as you have just said, is an Australian company that seeks to make access to energy more democratic, affordable, and also efficient for all. So some of you might not know that Australia is one of the countries where energy is more expensive. So it was the natural birthplace for a project like this. So the ballooning energy prices are mostly blamed on the transition from coal-fired energy towards the greater adoption of distributed renewables. So in the past 15 years, a lot of renewables such as solar and wind have been installed. So most of these renewables were installed by government subsidies, but these subsidies have been cut back. So hence the high energy prices. So amid the wider debate, the main question here is, are the renewables to blame? So the point that those opposed to the move toward renewable mix is that the grid is only as good as the market that sits behind it. So you see the traditional grid used to be simple. So they used to have vertically integrated utilities who sat in between a consumer and the large energy generators. So the utility would decide where and when to build the generating capacities. So they also decided how to bridge the gap between generation and also the consumer loads. So however, the shift toward this distributed renewable generation, so it's increasingly shifting the balance from the utilities toward the edge of the grid, where the now consumers becoming prosumers. So as a young researcher in this domain, I can say that mostly many of these issues stem from the management of renewables rather than the transition from coal to the renewable, to the renewable themselves. So we therefore need a flexibility market to ensure that we have right price signals in place. So this will ensure a seamless transition to from the coal to these renewables. So what PowerLedger is doing, so they are to address these challenges, that they are imagining the grid as a decentralized, trustless peer-to-peer energy trading system. So they have combined two innovative technologies, which is blockchain and solar power, and developed a software that is used in more than 9 countries for tracking and also trading of electricity, flexibility services, and also environmental commodities. So for example, this is a quite interesting case, example use case. So they have a project in partnership with Carlton United Breweries. So the conic VB, so the Carlton manufacturer is a VB beer manufacturer. It's quite common beer here in Australia. So where they are onboarding households with rooftop solars, and they are selling the solar, the customers or the solar owners would sell their excess or surplus energy from solar to the beer manufacturers. In return, they're being paid with cans of beer. Quite interesting. So, but what they're doing with PowerLedger in this case, they're using blockchain to track where is this energy coming from? Is it really coming from a rooftop solar? And in exchange, so they're also tracking the payment of cans beer back to the rooftop solar consumers. This way, the two companies can cut through the complexity of again. So in this way, these two companies, this is PowerLedger and the beer manufacturer, will cut the complexity and introduce the flexibility in sustainability, or ensuring that we bring into sustainability. So this, of course, brings the question, flexibility markets are likely to depend on local regulations and also permits. So especially PowerLedger, if it has to roll into the main grid. So this is a question to you, maybe Anthony or anyone in the group, to sum up. So do you think the governments are willing to listen and open up their mind to this kind of technologies? And also the second question, I think Gian also raised it. So PowerLedger software is based on Ethereum blockchain, which uses proof of work as one of its consensus mechanisms. And so the question is, isn't it therefore counterintuitive to use blockchain to provide energy solutions as they have high energy footprints and also high transaction costs? So, take a listen.
Samuel, absolutely smashed that one. Thank you very much. And shout to VB, shout to PowerLedger and VB coming together. If the citizens don't want to be paid in real Aussie dollars, then maybe they could be paid in beer. I like the circularity of that to some extent. And genuinely the benefit of PowerLedger is being able to provide the administration platform that sits between those multiple parties, right? What we're trying to do is to maximize the efficiency of how much energy that is being used or consumed or produced, and trying to optimize that system. Right. And traditionally, that's always been difficult. You've had energy utilities put in the middle to be able to manage the transmission, the distribution, the payments. Power is basically just production, transmission, consumption, and admin. And it's a perfect system for decentralization. And if you look at other jurisdictions, Equity in Europe is doing a similar kind of grid balancing solution where you're looking at also storage, including storage from electric vehicles or electric batteries. There is definitely progress in this space. So Samuel, I'd be very positive about it. On the proof of stake versus proof of work and use of Ethereum, it's not necessarily that they're using mainnet Ethereum for every transaction all of the time, especially given the number of transactions that a platform like this that's using real-time, kilowatt and meter monitoring. I suspect they're using some sort of scaling solution, some sort of level 2 solution specifically to help them bundle or kind of consolidate transactions. And when you look at that from an energy consumption perspective, it starts coming down closer towards kind of traditional cloud computing. But probably one to take away, if Anya's listening, Anya from PowerLedger, good friend of the show, definitely somebody can come back to us on this one, because that's a question we think we'd all love to see. Anybody else got any thoughts on PowerLedger? If not, we're going to jump to Pooja next. Pooja, I believe you want to talk about Ocean Protocol. Shout to Bruce Pond, shout to the whole Ocean Protocol crew. Take it away.
Sure. Thanks, Anthony. So before I talk about Ocean Protocol, I would like to start by talking about how the data is handling current situation, then why I think Ocean Protocol can be a next big thing. So we are producing more data now than ever before, and it is all around us, growing exponentially from people, companies, and devices. And no one truly knows that how fast we are producing this data. But here's a fun stat from a European Commission study. Like, according to their report, the world creates about 29,000 gigabytes of data every second. And they estimated that the value of the data market is worth trillions of dollars a year. So what happens with all this data? So, well, one key data consumer is AI, particularly deep learning. And the more data is fed into the AI models, the better these AI models become and capture more value. So every person generating a stream of data, the problem is that we don't own it. Currently, these data is logged by many big tech companies like Facebook and Google, who are basically data-driven companies. And we give up our data for free to these companies, and these incentivize the data by tailoring and targeting ads back to us. So I read one report on internet that estimated that an average US consumer can make $240 per year just by monetizing their data for digital advertising, which Facebook is currently earning with their data. So data is a valuable resource, and it can be used to power innovation and lead to breakthroughs that save lives, reduce cost, and improve the quality of our environment. So, like for an instance, every year, over 1 million lives are lost in car accidents, and countless others are injured, and mostly because of human error. So autonomous self-driving cars point to a future where more people can get home safely. And if car companies could pool their self-driving car data, we could rapidly improve the AI algorithms and have safe autonomous cars on the road sooner. Another example could be climate change, which is one of the biggest concerns of humankind. And maybe the United Nations wants to solve that problem and get a bunch of climate scientists to start working on finding a solution. However, they might want to access private data from another country to solve that problem. So that poses a major question, that how can we unlock access to private data? And this is the gap that the Ocean Protocol fills. So Ocean Protocol is a decentralized Ethereum powered smart contract platform and running on proof of authority. And it is designed to allow businesses and individuals to conveniently unlock the value of the data and it uses ERC20 based data tokens to monetize it. So individuals or data providers, they can use Ocean Protocol to monetize their personal data while retaining control and privacy. And users wanting to purchase said data, known as data consumers like researchers, scientists, and data analysts, they can now access more reliable data sets that might have been previously unavailable or hard to find. So these data exchanges takes place in the Ocean Protocol marketplace. And basically, Ocean Protocol is that connecting layer that allows the data consumer to go to one decentralized place that act as a sort of public utility and connects them with the data providers. Another interesting thing which I find with Ocean Protocol is that it wants to unlock access to private data and allow people to use it without the data being released into the wild. Like, for example, money related data. So that's usually pretty sensitive. So how can people safely use sensitive data like your banking history? So many people don't want others to be able to download such kind of sensitive data onto their computer or giving them the option to give it or sell it to someone else. So basically, Ocean Protocol solved all that by keeping the data behind a firewall. So in other words, they want to protect that private data, but allow data consumers to train models with that data. So how they do this? So the solution is that they created a data privacy zone, which allowed a data consumer to send their algorithm into it and test their model privately with that data and allow the findings to be extracted. So every data on Ocean Protocol is represented through a unique data token, which wraps the data. And this essentially permits third parties to operate on the data without it ever having to leave the publisher's secure enclave. So in a nutshell, Ocean Protocol enables the safe sharing of data and it ensures payment to the data provider while guaranteeing control, audibility, and transparency to everyone. And I think it's a pretty smart solution if you ask me, and I see a lot of potential in this project, but I still think there are still a few gaps. Like, one of the burning question is like, in such trustless crypto-driven marketplace, you may have no idea that who the seller really are and if their data is even genuine. Like, data could be fabricated in a convincing manner to look like real data, or they based on replaying actual historical data with statistical variations, or they could be injecting biasness into this real data, or they are censoring or altering part of it, manipulating the data. So this is one of the burning questions which I think is there. So what are your views on these problems? Yeah.
What a good one. Pooja, thank you so much for that. And when we start getting into data challenges, the authenticity of data, the integrity of data, the identity of the source of those data, I think it's super interesting talking about the provenance of some of the data that goes into AI algorithms, being able to audit the source data from which machines, sensors, AI as deriving its conclusions from, because I think from an audit trail perspective, from an integrity perspective, I think that's super interesting. From spoofing the system, and that's something, I mean, that is a very, very deep level challenge, and it's probably going to take someone of Bruce's brain, not mine, to come back on how are they addressing that. And maybe I'd like to shout out to Bruce and Ocean, see whether they could come back and answer some of these questions to us. So maybe we'll pose that challenge to them. We'll get them to watch this particular segment and come back with some comments, if that's okay. Anybody else got any thoughts specifically related to Ocean Protocol or blockchains and data? I find it to be quite a sensitive topic some of the time. Anybody else got a particular feeling on this one?
If I can make money off my data instead of Facebook, sign me up. That seems like a pretty good deal. If someone's going to make money off my data, it should be me.
Yeah, I hear you. And we had Brave Browser on the previous Students React video as well, which was something specific to browser history, which I guess is much harder to spoof than other forms of data that might be on the marketplace. And I suspect there's also a degree of standardization, validation that goes on to identify those individuals before they're put onto the network, if there's some degree of permissioning that might be at play. But we're going to let Bruce and the team come back to us on that. Guntur, you're going to close the show, and it's another great one, another fan favorite from season 1 of Blockchain Won't Save the World. Guntur's going to talk about IOTA. Take it away, Guntur.
All right. So IOTA is actually a distributed ledger developed to handle transactions between connected devices in IoT ecosystem. And IOTA actually began life as a hardware project whose goal was to design a low-cost general-purpose processors, which aim to solve the key scalability and performance issues on Bitcoin blockchain by actually replacing its blockchain with Tangle. So I think Tangle is something that makes IOTA really unique, because Tangle is actually a decentralized acyclic graph, or you could simply call it a DAG, which is a system of nodes that's not sequential. So its node can be connected to multiple other nodes, but they're connected only in a particular direction, meaning that node cannot revert back to itself. So unlike any other platforms of blockchain that requires full node miners, so here in IOTA, full node miners are not required, because its new transaction is confirmed by referencing 2 previous transactions, reducing the amount of time and memory for transaction verification. So also an easily solvable and straightforward proof of work is added to the transactions as the final step. Actually, IOTA has been implemented in various applications. For example, in January 2018, Taipei signed an agreement with IOTA Foundation to begin testing IOTA to transform the capital into a smart city. And a few of these tests include citywide Tangle ID verification and air pollution monitoring. It will also give the citizens more trust in public services and government with the IOTA's data integrity. So there's also another vision by Volkswagen to use IOTA for data integrity and audit trails, basically to do live updates over the air on the Tangle. With vehicle ownership data being centralized, it's actually too easy to tamper and to store data, making it untrustworthy. So a decentralized auditable ledger like IOTA could actually solve this issue. But anyway, IOTA has been criticized as well due to its unusual design, of which it's really unclear whether it's going to work in practice. As a result, IOTA was rewritten from the ground up for a network update called Chrysalis, or IOTA 1.5, which was launched on the 20th of April 21, just recently. Anyway, to me, IOTA looks really promising because to me, it's kind of like combination of 2 big technologies in 21st century, the Internet of Things and the blockchain. But anyway, yeah, I'm not sure if you're going to see more popularity of IOTA implementation in the future. Yeah, what do you think?
Guntur, thank you so much for that. And a really nice way to end the show. I think it's the ability to connect IoT devices, sensors, vehicles, city elements to a decentralized network that's lightweight, that has the opportunity to validate transactions quickly and easily with low cost. When you talk about those digital capabilities, you start saying there's a huge amount of potential in being able to create that sort of connectivity, that sort of validation. A little bit tongue in cheek, but having Volkswagen talk about data integrity is something that is definitely give me a wry smile when I hear it. But this is certainly something that they're turning a corner, and if they're looking at ways that they can do that, and specifically vehicle data, the amount of information that's coming from vehicles on a regular basis, whether that can be used for public good, societal good. To some extent, there's a lot of talk about monetization of vehicle data as well, monetization of, is it my vehicle? Is the data owned by me? Is it owned by the manufacturer? And we're going to see some really interesting legal battles on that one, I think, because actually, as you're driving around, there's a huge amount of information that vehicle sensors, cameras, etc., could be sharing for providing public good. And you need that to be lightweight, low cost. You might need to be cross-border if you're connecting that up to things like Ocean Protocol to be able to start creating a marketplace of vehicle data or sensor data or traffic data, drone data, if you want to go there. Huge, huge potential. Really, really excited about this one. But because of its complexity, right? Scaling that sort of network is always going to take time. But I want to believe that IOTA is going to scale, or something like IOTA is going to scale, because the use cases or the requirements or the validation of those digital capabilities being useful is crystal clear. I don't know if anyone else has an experience with IOTA or tangles or DAGs. Anyone else want to come on this one before we close? If not, it leaves me nothing more to say. Thank you so much to the students of UNSW. You guys have absolutely smashed it today. Excellent research, excellent and well-argued concerns and validations. Really interested to keep your perspectives fresh. I'm going to go back to some of the protocols we've mentioned, some of the projects we've mentioned, and try and see if they can come back specifically on your questions. They'll do a much better job than I will, I'm sure, to be able to answer some of them. And obviously, shout to all the professors who've allowed you guys to take a little bit of time out of your days to join us today. So Professor Salil, Professor Raja, Dr. Helen, and Dr. Volkan. Shout to UNSW, shout to Sydney, shout to Australia. And guys, thank you so much for joining us.